Hi everyone, it's Mrs. Sommer here to talk about lesson 403, Factors that Affect Reaction Rates. In this lesson, students will be able to identify what will happen to a reaction rate when a change occurs to the concentration of the reactants, the temperature of the reactants, pressure of the reactants, the surface area of reactants, and adding a catalyst to the reaction. If you recall, a chemical reaction is the breaking and forming of new bonds, and a chemical reaction will only occur if particles collide with enough energy and the correct orientation. So the rate of a reaction can be impacted by 5 different factors. Write this down. Those 5 factors are concentration, temperature, pressure, surface area, and a catalyst. Rate is the speed of a reaction, the speed at which a reaction can occur. So how does concentration affect reaction rate? Well, increasing concentration provides a greater number of particles available to react. This increases the frequency of collisions. So if we look over here, a low concentration, we've got, this one, they're moving and they're moving over here. There's not as much chance of them reacting, but if you increase the concentration, there's a much bigger chance of them reacting. Think about school. Think about if you went to had a large school, actually right now, for kids who are at hybrid, there's not a lot of kids in the classroom, right? And so there's not a lot of chances of, even in the hallways, of kids running and bumping into each other. Now, let's put the entire population of RRHS back into school. What are the chances of that hallway collision reacting with somebody because you bumped into them in the hallway? A lot higher, because we increased the student population. So adding number of students to the same size classroom or the same size school increases the chances that there's going to be run-ins in the hallway. Increasing the temperature is increasing the energy of the particles. That means that they are moving faster. You increase the frequency of collisions because they're moving faster, and more of the collisions have enough energy to react. So our reaction rates increase. So temperature actually measures how fast particles are moving. So if you think about it too in terms of a school, what if everybody was running in the hallways? They were running so fast to get to their next class. The chances of collisions in the hallways is a lot higher because we've increased the energy of the particles, aka the students, and we've increased the frequency of those collisions that are going to happen, which is why there's no running in the hallways at school, because it will cut down on the rates of collision. So increasing your temperature increases the rate of reaction because it speeds those particles up and it gives those particles enough energy to have a reaction. Increasing the pressure of a reaction involving gases forces the gas particles closer together, which increases the frequency of collision. Now, imagine being in school, and imagine the person you can't stand the most. Now, imagine being in the big building, and you probably don't ever see that person, right? And it's okay, whatever. Now, if I increase if I put you in the stock room in one of the science labs with that person, now I've confined you and I put you guys both under pressure. Now, what happens? The chances of you two reacting is going to be a lot higher. So if we increase pressure, we're decreasing the volume. So increasing pressure, you decrease the volume. So you reduce the amount of space they have to react. And so by doing so, you're putting them closer together and you increase the frequency of the collision. So the pressure is the same number of particles, but in a much smaller space. With surface area, increasing the surface area increases the number of particles exposed. So increasing the number of particles exposed, it increases the frequency of collisions. So if we take this big block and we put it in water, it's going to react, or in some chemical, it's going to react. But if we break it up into smaller boxes, now we have, so on this one, you have this part, this part, this part, and then over there, and down here. Now you have this, you have what, 6 sides on the cube here? You have 6, 6, 6, 6, 6, 6, 6. So 1, 2, 3, 4, 5, 6, 7. So 6 times 7. So you have 42 different spaces versus 6 areas to react, which means that we've increased the frequency of collisions because more parts of the particle can be exposed to the other reactant. So surface area measures how many particles are exposed. So if you think about it in terms of something you might know, my son has severe food allergies. When he has a reaction, the hospital actually gives him either crushed up Benadryl, or more so they give it to him in liquid form. So the liquid form of Benadryl, so with a regular Benadryl tablet here, and then it'll, like, you give it to them, and then the stomach, you got to dissolve it in here. It takes longer to react, right? Well, if they give it to him in liquid form, so let's just draw those liquids here, or if we crush it up like a chewable Benadryl, there's more, it will react faster for him. And so it will help him with his reaction along with the EpiPen faster than if we were just to give him the 2 tablets to swallow, which is where surface area comes really into play with medications especially. Okay, a catalyst. Adding a catalyst decreases the activation energy needed. It makes it easier for reactions to occur. So a catalyst is a protein or an enzyme that helps a reaction happen by breaking bonds or aligning the reactants correctly. There are other catalysts, not just a protein, but that's where you're going to see it most often, is in the human body and with enzymes. So energy of reaction. So this is the energy of the reaction if there was no catalyst. There's this huge activation energy needed for that reaction to occur. But with a catalyst, it lowers the activation energy. So it makes the reaction go faster. So it makes it easier for the reaction to occur, so it makes reaction go faster. Oops. And your reaction rate increases. Your human body has thousands of different enzymes that we use on a daily basis in order to function. And if people are missing an enzyme, it makes it very hard for them to perform certain everyday things. Sometimes you're lacking an enzyme to digest milk. That's a common one. A lot of other things and a lot of different conditions are based on lacking certain enzymes. So an enzyme is something that lowers the activation energy. So your activation energy is going to be wee little bitty versus huge. So without the activation energy.